A compound inequality is formed by joining two inequalities with and or the word or in between. In this video, we are going to talk about compound inequalities. So again, that means two inequalities, and in between them, we're going to find the word and in this video. So the word and indicates that the solution is part of both sets. That means the number you're finding for x must work for both inequalities. So the symbol to show that looks like this. It kind of looks like an upside down horseshoe. So we'll talk about how to use that later in this video. I remember that symbol because to write the word and kind of looks like an N. So that's how I remember when the U or the horseshoe looking thing is going down like this, that represents the solutions of both sets. So when we graph, the shading will intersect. So to show that without inequalities, let's say that this circle right here represents being over 21. And then let's say the green circle here represents having, I'm going to put DL for driver's license, having a driver's license. So where the two circles intersect, that means they have both. So they're over 21 and they have a driver's license. So it says you must be over 21. So all of these people in this circle right here are over 21. But it says and. So the word and means you also have to have your driver's license. So these people here have their driver's license, but they can't get into this party. They have to be both. So that's similar to what we're doing with the inequalities. We have to find the values for x that are solutions in both. So the key thing to think about is the x values have to work for both inequalities. So let's go ahead and do an example. So it says solve each compound inequality. So compound inequality means you're going to have two inequalities, and in between it you'll have the word and or the word or. So this video focuses on and. It says graph your solution, write your answer in interval notation. Okay, so first of all, you look at this problem, and then when you see the word and, you should be thinking about both. The values that work for this x and also for this x. So we're going to solve these two inequalities just like normal, so get the x isolated. Remember when you're solving an inequality to switch the symbol if you divide or multiply both sides by a negative, so we did not do that here. But over here we would divide by -2. So that means the symbol here is going to be switched. So when we graph, we're going to graph our final answer. So it says graph your solution. So we're going to go ahead and do what I call a rough draft. Just like in English class, you do a rough draft before your final product here. So that's what I'm going to do here. So I'm going to make a graph, and the smaller number always goes first. Larger number, 5 is a little bit away from 3 here, so it's going to go right here. And I'm going to graph them both on one graph. So this says shade all the numbers, or shade the side that is greater or equal to 3. So I'm going to use a bracket because it has the line underneath. That's how I know to use a bracket. So I'm going to shade everything here. Okay, now I'm going to pick up a new color. And now I'm going to graph this. This says shade all the numbers, and this is like an L for less. So I'm going to shade the left side of 5. So it has the line underneath, so I know I'm going to use a bracket. And I'm going to shade all the numbers that are on the left. So the key word here was and. because it has the word and, we need to look where both the solutions are. And right here is where we have the green and where we have the brown color right here. Over here, we don't have both. Here, we don't have both. So the solution in our final graph, we only need the numbers from 3 to 5. And then we shade in between to show that all the numbers, including 3 and 5, everything in between, like 3.1, 4, 4.111, any number in between, including 3 and 5, would work in both of these inequalities. So to write our interval notation, we always go from the left to the right. So we did not need to use this symbol in this problem. So to make sure it's very clear what the word and means, it means that if we take our original problem that we started out with here, and we plug in any number here. So here's 3, here's 5, so a number would be like 4s in between, for example. I could use 3.1, I could use 3, I could use 5. And the point is that if it has the word and, we want the numbers that will work in both of these. So if I plug in a 4 right here, I would have 9 is greater than or equal to 8, so it works. If I plug in 4 here, I would have -2 times 4 is -8, and -8 is more than owing someone 10. So it works in both. Again, that's what the word and represents. So this is our solution graph, and this is our answer. All of this helped us get what we needed. Okay, let's go ahead and try another example. So let's go ahead and solve both of these inequalities. Feel free to pause the video and get the y's isolated, and then you can push play and see if you did that correctly. So when we're solving the first inequality for y, we get 4 divided by 3. 3 does not go into 4, so we can leave it as 4/3, or you can write it as a mixed number if you want, but it's not required. You don't want to leave it as a decimal because it's not exact. Now go ahead and solve the second inequality if you haven't. Okay, so once we have both inequalities isolated, where we have the y by itself, we're going to make a rough draft. We start with the smaller number, so I'm going to go ahead and put 4/3, because 4/3 is a little bit more than 1, and this is 4, so the bigger number goes on the right. And I'm going to start with this one. This says shade all the numbers that this makes an L for left or less. So I'm going to shade all the numbers that are on the left side. Notice I'm putting a parenthesis here because there is not a bracket or there's not a line underneath, so it means don't include 4/3. Okay, now here, same thing. This makes an L for left. So I'm going to shade all the numbers on the left of 4, and I'm going to also use a parenthesis. Okay, so we graph both of them on the same graph as our rough draft, and then here's our key word. If it has the word and, it means we want where both of the solutions are. So that would be right here. Not here. There's no shading here. Not here because there's only shading with this inequality, but here's where both of them are. So our final graph would have 4/3 and all the numbers shaded to the left of 4/3. So we don't need any of this because these numbers here don't work for this inequality and this inequality. These numbers here only work for this one. So we are omitting this from our final draft, or for our final copy of our graph. So from the left to the right, that's how we do interval notation. So it's going to the negative side infinitely, comma, and then it stops right here at 4/3. So that means it could be anything less than 4/3.